Hey there, welcome to video number 3. Today we'll be discussing about stripped versus non-stripped binaries, and we'll try to understand what are the difference in terms of symbolic information in that file format. So basically in this video we dive into the world of ELF, which is nothing but executable and linkable format files, exploring their significance in software development and critical difference between stripped and not stripped binaries. We'll also uncover how the strip, read, elf, and the file utilities play a vital role in understanding a binary. So let us first look at what is a ELF file format. So the ELF file format, as I have already mentioned in my previous video, is a widely used standard on Unix-based system for executable shared libraries, object code, and other binary files. It provides a structured way to reorganize and represent the various components of a binary, making it portable and flexible across different architectures and operating systems. So, if you remember in the last example, in the last video, we looked at this code. It's a basically a hello world program. As you can see, we just have this hash include followed by this has define, and in the main function we are printing just the message hello world. So let us first compile this c compilation.c file, and let's create an object file called example for our demonstration purpose. So if I run this example binary, you see this is same as the c compilation.c source code, and we have this hello world print. So there is another utility in Linux which is called file, and if you further examine the created output file, you will see that it is showing that this is a ELF format. So basically all the executable files which is based on Linux or Ubuntu systems are basically follow this format of ELF file. There are a bunch of other utilities which I would also like to mention before diving into the strip versus non-strip binary. So there is another function called strip, and if you look at the help function, there are multiple things which you can strip. So basically the strip utility, which is a part of GNU Binutils package, empowers developers to manipulate ELF binaries. By using the strip command, developers can remove or strip debugging symbols and other non-essential information from binaries. This process results in a smaller file size, basically making strip binaries ideal for production and release versions of software. Additionally, stripping a binary enhances its performance by minimizing memory consumption and reduces the risk of exposing sensitive information to the potential attacker. So if you type this strip help, it will give you multiple options. So for example, there is an option that remove all symbols and relocation informations, or remove only all debug symbols and sections, or remove all symbols not needed by relocation. So given a binary, there are plenty of options which you can use to actually strip all the extra information, which is really helpful to understand what the binary code is doing. Apart from that, there is another utility called readelf. Basically, readelf is a utility which is another component of GNU Binutils package. Is a powerful tool used to inspect and analyze the contents of ELF binaries. With readelf, developers can delve into various aspects of ELF files such as header information, section headers, symbol tables, relocation information, and more. It proves to be an indispensable tool for examining the symbol table of not strip binaries, basically, which is very crucial for effective debugging and error analysis. So if you do this readelf minus minus help, then here also you will see a multiple options. For example, if you call readelf with minus h, it will basically display all the ELF file header information. Or if you need the section headers, you can do it by minus s. Or if you want to section groups, minus g, and etc etc. There are a bunch of other stuff. Okay, so now let's start with the actual motivation of our strip versus non-strip binary. To reiterate, we'll explore a crucial aspect of software development and security, that is the difference between stripped and not stripped binaries in terms of available symbolic information. So if I again show you what this newly generated example file is, you can see it is showing not stripped. So using this file utility, you can know whether a binary is a stripped binary or a non-stripped binary. But let us first answer the questions: what are stripped and non-stripped binaries? Let's begin by understanding the basics. Binaries are the compiled output of the source code, as we have seen that this C compilation.c file we compiled using GCC, containing machine code that computers can directly execute, right? Which we compile our When we compile our code, two types of binaries can be generated: the stripped and not stripped. So right now we generated a not stripped one. Stripped binaries are produced by removing most of the debugging information from the executable. This results in a smaller file size and more compact binary, making them ideal for production and basically releasing the software versions. On the other hand, not stripped binaries retain the full debugging and symbol information. These binaries are larger in size compared to stripped ones and are typically used during development and debugging phases. Now let's take a closer look at this not strip function. Not strip binary. So every binary has this symbol relations stored in the symbol table of a binary. So to look at that, we can use our readelf utility with this s command. So if we go to this s command, minus small s, basically it will display the symbol table. So if we do minus s followed by our binary, which is currently the not stripped one, let us see what it is looks like. So this is the complete, starting from here is a symbol table. So what is a symbol table? Basically it gives you a mapping to some kind of higher abstraction from the binary code. For example, if you look at, see, this is a symbolic information for main function. That means if you have the binary code, this from this location the main function is starting, and it is of 23 bytes. So when you look at code of a binary for it, let me show you. Check dump example. Let me show you how the disassemble code look like. So if you come at the main function, so this is the disassemble code of the same binary, and you can see the main function is starting at this address, which is also shown somewhere here. See, 1180, and here also main function is 1180. And if you count the bytes starting from 1180 to 1190, it is basically 23 bytes. Now, if you see the symbol table again, see there are other kind of symbolic information which are mapped to directly in terms of memory address in a binary. For example, for example, at this location, uh, these are the dynamic library functions which are to be called while the code has been loaded to the operating system. So if you see, starting from here, we have like lots and lots of symbolic information, and we know so far the binary we are considering is basically a not stripped one. Right. But when you go to strip binaries, we will have a closer look at strip binaries basically. So when you strip a binary, so first let me tell you how stripping is done. So you just call this strip binaries. Let us look at the options, and we are going to strip basically all of them if possible, which is again minus s. So we'll call this strip function minus s, and then we feed our binary. Now, once this is done, if we again look at this file utility, now you see there it is basically a strip binaries, and using this strip utility, you can strip a binary. So when we strip a binary, basically we remove most of the debugging symbols such as functions and variable names. As a result, the file size is reduced, right? So if you want to look at the sizes of the file also, I'm quite sure this will be a reduced version. um, and it may lead to faster loading times and lower memory consumption in production environment. So basically, when you have a company and you want to release a product, you release a step version because you don't want others to get a mapping from this binary code to actual higher level code. So if that says what happens, then they can also duplicate your product, right? So that is why basically stripped is used. Now, let us look how the symbolic table still looks like in our strip binary. So to do that, we'll again use this readelf minus s an example. Okay, if you let's recover, this is the symbolic information, which is a quite a big for a non-strip version. And now if you look at the strip version, you can see it's just the dynamic symbols they are retaining, nothing else. You don't know from where the main is starting, and there is no way you can reconstruct it back. There are some heuristics, but there is no definite way. You may ask why these dynamic symbols are still there, because these dependencies are not resolved during static time. Once the files are loaded into the operating system takes exact measurements to resolve this and assign the actual memory address. So that is why this dynamic symbol information is very important, and even the strip utility don't remove that. So, in conclusion, understanding the difference between stripped and not stripped binaries is vital for software developers and security analysts. Stripped binaries are preferred for production environments due to their reduced file size and limited exposure of sensitive information. Conversely, not stripped binaries are invaluable during development for their comprehensive debugging information. And by following best practices, we can effectively manage and deploy these binary types to build robust and secure software. That's all for today. Thank you for watching, and happy coding, and see you in the next video.